Hey everyone, till now I discussed how can design the AR diagram. In today's lecture I will discuss how can convert AR diagram to relational schema. Both AR diagram and relational database are the abstract logical representation of the real world enterprises. Because two models employ the similar design principle, we can convert AR design into relational design. Means one AR diagram is given, from that we can create the real relational table. We'll discuss one by one how can convert AR model into relational schema. First we'll discuss how can convert strong entity set with simple attribute into relational schema. Next we'll discuss strong entity set with composite attribute. Then weak entity set, then different type of relationship, right? So for each strong entity set, how many attributes are in AR model, same thing we'll write in the relational schema. Okay. Suppose E is a strong entity set with simple descriptive attribute like A1, A2 till AN. Then that same we can represent in relational schema. Let E is the table having n distinct attribute and A1 to AN that we can write. And primary key will also be same. What is in AR model, that will be in relational schema. So for each strong entity set, we will create a separate table and list of attribute will be same, primary key will be same. The primary key of the entity set serves as the primary key of the resulting schema. For student entity set, attributes are ID, name and total credit. That same we can create in the relational schema. So we will create a table. First will be ID, then name, then total credit. Okay. And each row will be for each entity. Now some more examples of schema having strong entity set. In previous lecture I discussed complete AR diagram of a university. Now from that AR diagram we'll write some strong entity set. Like for classroom, building, room number are the primary key, then capacity. For department name is the primary key, then building, budget. Then for course ID is the primary key, then title, credit. For instructor, ID is the primary key, then name, salary. For student, ID is the primary key, then name, total credit. So for strong entity with simple attribute, we'll create a separate table. Attribute will be same, primary key will be same. Next, representation of strong entity set with complex attribute. For example, in instructor entity set, name is a composite attribute. It consists of first name, middle name, last name. Then street is a composite attribute. It consists of street number, street name, apartment number. Then phone number is a multi-valued attribute, whereas age is a derived attribute. So these are not simple attribute, these are the complex attribute. Composite attribute, multi-valued attribute, derived attribute all comes under complex attribute. So how can we represent this complex attribute in the relational schema? We deal composite attribute differently. We'll write first name as one attribute, middle name as one attribute, last name was one attribute, and we'll not write this name. Okay, so we'll create separate attribute for each of the component attribute, and we will not create separate attribute for the composite attribute itself. Means in the table directly we'll write first name, middle name and last name. Okay, and there will be no name. Now for street number, street name and apartment number. So that we can write without writing the street. So street number, street name and apartment number, that will be separate attribute, will not mention street. And multi-valued attribute treated differently. Like your phone number is a multi-valued attribute. For multi-valued attribute, we'll create a new table. Okay. Composite attribute, that we can write in this same table, but for multi-valued attribute we'll create a new table. And for derived attribute, we need to write a method how can derive, like how can derive age from date of birth, that we can write by some method. Okay. Now the attributes of instructor without including multi-valued attributes are ID, first name, middle name, last name. See, we are not writing name. Then street number, street name, apartment number, city, state, zip code, date of birth. We are not writing age. Age is a derived attribute. We are not writing phone number. Phone number is a multi-valued attribute. For phone number, we will create a separate table. So these are the simple attribute. There is composite attribute, but we break composite attribute to simple attribute. Like we break name into first name, middle name, last name. We break street into street number, street name and apartment number. So if there is composite attribute, just break that into simple attribute and write directly the simple attribute in the relational schema. Now for multi-valued attribute, we'll include the primary key of the main entity set. So for phone number, we'll include the ID of instructor as ID is the primary key. So now for instructor entity set, phone number is the multi-valued attribute. We can include the ID attribute with the phone number for instructor phone relation. So we'll create another relation, another table for instructor phone where we'll just keep ID and phone number as attribute. Suppose we have two phone number 555-1234 and 555-4321 for same ID 52. Okay, so that we can write as ID with first phone number, then ID with second phone number. So here ID with first phone number, then ID with second phone number. Combinedly ID and phone number consider as the key. In addition, we create a foreign key constraint on the relation schema created from the multi-valued attribute. So here foreign key is the ID that reference to the instructor relation. Okay. So the relation instructor phone have attributes ID and phone number. Here ID is the foreign key that reference to main instructor table. Okay. So for strong entity, if there are simple attribute that we can write directly, primary key will be same. If there are complex attribute like first composite attribute that we can break into simple attribute, and if there are multi-valued attribute, for multi-valued attribute we'll create a separate table and include primary key of the main table plus that attribute. Like for phone number we include ID and phone number. For derived attribute we'll write the method how can derive that attribute. There are no separate table. In today's lecture, I discussed how can convert strong entity set with simple attribute and complex attribute into relational schema. In next lecture, I will discuss how can represent weak entity set. If this lecture is helpful for you, please like, share and subscribe. Thank you. Bye-bye.